Okay, humans, we're gonna tackle some equations here that have fractions in them. Not a big deal. We use the same process. There's just some scary fractions. Before we begin, we must look at how we divided fractions in the past. We have 3/4 divided by 5/3. But remember, we had the cute little saying of keep, change, flip. Keep the first, change the sign, keep the first, change that sign, and flip the second. So instead of 5/3, we have 3/5. And we multiply straight across. 3 times 3 is 9 on top, and then 4 times 5 is 20. So there we have it. The moral of the story is that if you divide a fraction by a fraction, it's the same thing as multiplying by the fraction's reciprocal. So anything that you divide by a fraction, like so, 2 divided by 3/5, is the same as saying 2 multiplying 5/3. Dividing by a fraction is the same as multiplying by its reciprocal. Dividing by a fraction is the same as multiplying by its reciprocal. Okay, here's a fun example. We've got an equation here that we have to solve for x. Here's x. Is there anything we can do to simplify the left side? No. Is there anything we can do to simplify the right side? No. Okay, let's tell the story about x. X is being multiplied by 3 seconds and subtracted by 2. So let's add 2 on both sides. Here we go. We're on our way. 3/2 x. Nothing's here. Equal sign, and 7 and 2 is 9. What's happening to x? X is being multiplied by 3/2. So we have to divide, right? Divide by 3/2. Wait a second. Dividing by a fraction is the same as multiplying by its reciprocal. So instead of saying divide 3/2, what I'll say is multiply by the flipped version. If I multiply by 2/3 on this side, I better multiply by 2/3 on this side. On the right, you'll have 9, which is over 1. And you multiply straight across when dealing with fractions in multiplication with one another. 9 times 2 is 18, and 1 times 3 is 3. On the left, you'll have 2 times 3 up top, which is 6. And then on the bottom, you have 3 times 2, which is 6. 6 over 6, oh my gosh, it's 1. It's almost like we wanted that to happen. It's almost like we wanted 1x to be equal to something. 18 divided by 3, which happens to be 6 today. To review, if ever you have something right next to x equals another number, of course you divide the first here on both sides. But if that number happens to be a fraction, all you have to do, instead of dividing by the fraction, multiply its reciprocal. So let's see. Each of these is a simple one-step equation where x, or the variable, is being multiplied by a fraction. So in order to solve these, in order to solve for our variable, we'd have to divide by that fraction, or multiply by its reciprocal. In the first case, I hope you can see that you would multiply each side by 2/7. 2/7, and you'd be able to find a good answer. On the right, you'd have 24 over 7 is equal to x, and you'd be done. This is too easy. For this next example, 3/4 is multiplying m, so divide by 3/4, or multiply by its reciprocal. 4 over 3, the flipped version of the fraction. And lastly, I hope you can see the pattern here, and you just need to multiply this idea by its reciprocal. Be careful, it's negative. 4 over 7, be careful, it's negative. Negative 12 over 7 equals what you wanted it to be, just a p. How you feeling? Something I want you to notice, that every time you multiply a fraction by its reciprocal, you achieve 1. 5 times 2 is 10. 2 times 5 is 10 equals 1. 60 over 60, oh my goodness, is 1. Anytime you multiply a fraction by its reciprocal, the flipped version of that same fraction, you get 1. Pretty exciting stuff, I know. There's a couple of ways you can do this problem. I'll do it the long way. Double rainbow all the way across the sky. You've got 2/3 times x. 2/3 is multiplying x, there it is. And then 2/3 is multiplying 6. 2/3 multiply 6, which is really over 1. So on top you've got 12 over 3 times 1 is 3. Okay. Here we have it. So we've got 2/3 of x plus 4 is equal to 3. Well, there's nothing more I can do on either side. Let's tell the story and then undo it. We're subtracting 4 on both sides. You've got 2/3 with x equals -1. X is being multiplied by 2/3, so divide by 2/3. Oh wait, that's the same as multiplying the reciprocal. Sweet, I'll do that on both sides. And we're left with x is equal to 1 times 3/2 is 3/2, and it's negative. Not a big deal. Do you hate fractions? Well, I've got the plan for you. Here's another approach to solving those pesky equations that have fractions in them. You can either do what we did last time, but you'd be adding and subtracting fractions if you have an equation with multiple fractions in it. So here's the best strategy for dealing with an equation that has multiple fractions. Go ahead and multiply through by the least common denominator. In this case, what's the denominator that each of the denominators can go into that's the least number? It's not 4 because 8 can't go into 4, but it is 8 because 4 can go into 8. And 8 is the least number that each of your denominators can divide into. So let's go ahead and multiply everything through by 8. So it's like a triple rainbow in this case, triple upside down rainbow as pictured here. You've got 8 multiplying x over 4, and 8 multiplying 3 over 8, and 8 finally multiplying this 2 on the other side of the equation. Now that we've multiplied 8 by everything, we haven't changed anything because we did the same thing to everything. All right, let's condense this a little bit. Let's bring it up here, and let's see what we have left. Again, when multiplying fractions, you've got 8 times x on top and 1 times 4 on the bottom here. Here you have 24 on top and 8 on the bottom, and then you have 16. Watch the magic that happens. 8 divided by 4 is 2 with an x. 24 divided 8 is 3. And this is equal to 16. Oh my gosh, we just got rid of the fractions. And now we have an equation that looks super duper attractive and we know how to solve it. Tell your story and undo it. In fact, I won't even do this one because you can do the rest of the way. Think for a second. How do I solve this equation? Well, if you hate fractions, like I do, I don't. You can multiply through by the least common denominator. In this case, look at your greatest denominator, 5. Does 4 go into 5? No. Well, you can always multiply the two denominators to figure out a common denominator. So let's do that. 4 times 5 is 20. If we multiply through by 20, we'll get rid of all the fractions. Awesome. Let's do it. 20 times the first idea, then 20 times the second idea, and then 20 times the last idea out here. Here we have it. On top we've got 60 over the 4 with the x. Here we have 40 over the 5. And lastly we have 60. Oh my gosh, this is exciting. 60 divided by 4 today, I think it's 15. X minus 8 equals 60. And by golly, this is an easy equation to solve. And so on. 68 equals 15x. X is being multiplied by 15, so divide by 15 on both sides. X has a value of 68 over 15. You may be able to simplify that, maybe not. I don't know, but that is the form of your answer. Oh my gosh, this is so exciting. It's that time of day, ladies and gentlemen. Go ahead and try this one and see how you fare. Multiply through by the least common denominator, and maybe, just maybe, you'll get an equation that has no fractions and easily solved. Good luck.